in module 4 of computer organization you have 8 things. Like this is the first thing, like n bit ripple carry adder. Okay, for each you have to remember some steps, and then if you remember those steps, if they ask those questions you can hopefully solve them. Okay, now see, if they ask to explain n bit ripple carry adder, what you have to do, first make 3 boxes. Okay, x and y are the input, so x0 y0 x1 y1. Okay, and this is carry will come from here, x and y. Okay, then this is s0 means sum. Now sum will come from here, and c1 means the carry output. Okay, that will come from here. So 3 inputs and 2 outputs, like that it goes on continuously. That is n bit ripple carry adder. You can explain this in your own words if you know what is x, y, s1 and c1 and cn plus 1. Okay, now then write these equations for si and ci means ci plus 1, next carry input. Okay, so that will be the 2 equations, and you can explain it in your own words. This is the second type. Here you have carry look ahead addition. This is same as the previous one, x, y, c. Okay, and s will be output here, but the thing is the c will be given from here also, and for each c will come from here. Okay, c1, c2, c3 and all. Okay, that's the only difference between carry look ahead and the previous one. Okay, so what you need to do here, gi is a new thing here, gi pi. So what is gi means? Gi is xi yi. Okay, the multiplication, and pi is xi plus yi. Okay, ci plus 1 is the next carry, which will be gi plus pi ci. Okay, this is the previous carry that is getting multiplied with pi and added with gi. Okay, and si is simple, it is xi plus yi plus ci. Write these 4 equations and explain what it is, all these terms, and this is carry look ahead, which has the sequence of carries. Okay, this is an important one, sequential multiplier. Okay, if they ask in exam what you have to do, you have to take 2 numbers. Suppose I have to multiply 13 and 11, which answer is 143. In binary this answer. Okay, take m as this, 13 as m, and q as this. Okay, then what you need to do, the step 1 you have to write like this, m is 1101, which is 13th equivalent. Write c here and make a box, a and make a box, and similarly for q also, and remember this last value is q naught. Okay, that's your first step. Now what you need to do in step 2, if q naught is 1 means this one, if this is 1, what you need to do, add m to a. Now m is this one, right? You have to add m to this, means a is equal to a plus m. If you add this to here, what you will get here, a as 1101, a was 0, so whatever be the value of m, that will be coming here. Okay, so that's your step 2. If q naught is 1, then you need to add. If q naught is 0, you need not add, you just copy what was the previous one and go ahead. Now coming to the step 3, what you need to do, right shift all the bits. Okay, now see, right shift means this 0 was here, right? This will come here, this 1 will come here, and similarly all will go like this. Okay, when this will go, the last bit will be cut off. Okay, then this q naught will be there, that means q naught is 1, right? Then again you need to do addition. Okay, step 4, add. Now again you need to add this 1101 plus 0110. When you add this, you will have a carry here, you add and see, you will get a carry that you have to put here. Okay, carry will be 1, like that. If you add, that carry will be there, and you will have to write what will be the sum. See, this is a register. Okay, this is a. Now what you need to store, see, let's see, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, carry will be 1 here, since carry is 1 here, 1 plus 1 again here 0, and that carry again 1 will be there, that will be here. Okay, so that's the way you do. Now again you need to check if q naught is 1. Okay, like q naught will be this, right? Q naught has gone from here, again this will be here, q naught is again 1, so you need to add again, and so on you need to do until and unless the number of bits will be there, how much, that many number of times you need to iterate. Okay, if they ask you Booth algorithm, this is Booth algorithm. Okay, how to do this one? First step, you need to remember this table. Okay, means bit I and bit I minus 1, means if there is a bit before that bit also it is 0, what you need to write, 0 into m. Now let's see with an example. First remember this table. Okay, now let's see how it is. Now see, suppose this is the bit given. Okay, now see, you have to add a 0 here at the first one. Okay, before the number starts, you have to add a 0 here. Now compare these both, 0 and 0. For 0 and 0, what it is, 0 into m means 0 only, right? So it will be 0 here. Now again you will compare these both. Okay, 0 0, it will be 0. Now 1 and 0, you have to compare 1 and 0. See here 1 and 0, what it is? Minus 1 into m. Just write minus 1. Like that 1 and 1. What is for 1 and 1? It is 0. Right here 0. Like that do for the whole binary number which they give you. Okay. Then next, for example, it's a small thing only, you can easily understand what it is. Now see, suppose I have to multiply two numbers 13 and 6. Okay, in exam if they ask you, you have to take an example like this. 13 into 6 is 78. Write the binary equivalent for 13, binary equivalent for 6. Take 13 as m and q as 6. Okay, now what you need to do, you need to apply both pairing on q. Q is 0 0 1 1 0. Right here 0 0 1 1 and here it's 0, but you will put an additional 0 here. Okay, always. Now you will check for 0 and 0 it is 0, 1 and 0 it is 1 in the boot table. Write that for all. Then after that what you need to do, write m here and this q which you got right here like this only, 0 minus 1 0 plus 1 and 0. Now it's 5 digits, right? So in the product you will have 10 digits total. First you multiply this, 1 into 0 is 0, 0 into 0 is 0. Like that for all you will multiply and write 5 digits here. Total should be 10 digits. So again 5 zeros you will put here. Similarly for second one, 1 into minus 1. Now what is minus 1? M is 13, right? So this is 13. Minus 1 means minus 13. Find that binary equivalent of minus 13, which is 10110. Write that here. Okay, by multiplying with minus 1 you have to write that minus 13 decimal here, and what it will extend here, that is the final digit here. Okay, whatever you get here, that you should extend here. In this case again here it is 0 in the third step, so here you will write all this and extend this last digit till the end. Like that only, you have to leave one space for each step. Okay, one space for each step. Then after you complete this, add it normally, like 0 will be here, then 0 plus 1 is 1, 0 1 0, like that full you have to write the final answer. This is the final answer which you get, which is the binary equivalent of 78. Okay, this is the fifth topic which they can ask in exam. It is bit pair recoding of multipliers. Okay, here also similarly like that previous one, you will have the table here, you need to multiply, you need to memorize this table. If the I plus 1, see if ith bit is there, next bit and the previous bit both you will compare. All right, if it is 0 0 0 you will put here 0, if it is 0 0 1 you will put here 1. Okay, like that. Let's see by an example how to do. This is the first step, memorize that table. Okay, suppose the number given is starting from here 1 1 0 1 0. Two things you need to do here. First you will put 0 as the previous one and you will extend the sign here. If it is 1 you will put here 1, if it is 0 you will put here 0. All right, then you will divide it into three parts. Take the first three, 1 0 0, look into that table and write the value here. Then for next 3 write the value, for next 3 write the value. After doing that you will get here one number, right? Now what you need to do, in the step 3 you have to multiply 13 into 6, which is 78. Okay, take m as 13, q as 6. Now when you do the both pairing, by looking into the table you will get 0 plus 2 and minus 2. Okay, for q, that you will write here, write m here and write here 0 plus 2 and minus 2. For this what you need to do, multiply this one with minus 2, means if m is 13, what is 13 into minus 2, it is minus 26. Find out the minus 26 binary equivalent and write here and extend the sign till the end. 10 digits. Okay, since this is 5 digit number, you will have 10 digits in the answer. Then leave 2 digits and multiply the second one, 13 into 2. Okay, what is 13 into 2? 26. Write the binary equivalent of 26 after leaving 2 spaces here and write the zeros here. Okay, after doing all that you need to add 0 1, normal addition, you will get the answer finally here. Okay, it's good if you find out 2m and minus 2m in advance. Okay, in case if minus 2 and plus 2 are there, it will be helpful for you. Okay, see 2m is 0 1 1 0 1 0. This is the binary equivalent of 26 and binary equivalent of minus 26. So respectively, when you have minus 2 here, when you will multiply this in the first step, you will write this minus 26 here. Okay, you can take the same example which is given in the notes also and learn it how to do. Okay, first step, what you need to do, 45 and 63 you need to multiply. Write the binary equivalent of 45 into and 63, then do it normally. Okay, like you will multiply this whole by 1, 1 1s are 1, 0 into 1 0, 1 into 1 is 1, so you will write that and you will leave one space and you will do for this one, this whole you will multiply by this and write here. Okay, so like that you will do all then you will write A, B, C, D, E, F. Okay, A represents this one, B represents this one, and C, and like that. Okay, you have to write that full and you will add it. Okay, this is your first step. Now in second step, what you need to do, remember this table very carefully. The same you need to do in the exam as well. Okay, FED remember it as you can by your own techniques or any tricks. Okay, remember this table. If you remember this table, the rest of the things are very easy for you. Okay, now what you need to do, remember the sequence here, A plus B plus C. Okay, that is S1 and C1. Now see here, I remembered it using this way. If A, B, C are there, S1 and C1 will be there. Okay, I'll show you how to add these things like that, FED, and for all this I have written here. Okay, if you want you can use the same way. Okay, then in next step what you need to do, you had got A, B, C, right, which represents A. I had told, write that here, A, B, C. Okay, in the same order, leaving one space. Okay, maintain the spaces, it's very important. When you write all this, then what's the next step? What is S1 and C1? Suppose you need to find S1. What is S1? This 1 is S1, and there is no carry. Since only 1 is there, carry is 0. You will write carry in the next place. Then 0 plus 1 is 1, and there is no carry for that. Similarly, 1 plus 1 is 0 and carry is 1. You will write 0 here, which is sum, and carry as 1. You will do the same thing for whole, and this represents S1 and this represents C1. Similarly, for the DEF also you need to do the same. For DEF, you will write here, maintain the spaces very carefully. Okay, see, A, B, C were here, and after this C got over, one space, D starting. Alright, so in that form you need to do that, and you will find the S2 and C2 in the same way as you found for ABC. Then you need to do carefully from here. You need to take S1, C1 and S2. Okay, if you add these three together, you will have S3 and C3 in the same way. 1 plus 0 is 1, carry is 0. In that same way you do, you will get S3 and C3. Okay, after getting S3 and C3, you have to add S3, C3 and C2. Then you will get S4 and C4. Whatever sum you get, you will write here, and whatever carry you will get, that you will write in the next place. Okay, like that for whole you need to do. Then at last add S4 and C4 to get the final product. If you do this much, you can expect good marks. Okay, let's start by taking an example. Suppose you have to divide 8 by 3. Okay, what you need to do first, write here M and Q. Write the binary equivalent of M, which is 3, and Q, which is 8, right? Okay, then take register A below M. Write all zeros initially for A. Step 1, what you need to do, left shift A. Left shift means these values will come here. Suppose left shift means C. This is 1 0 0, right? This will move one place to the left. So 0 0 0 will be remaining, and this 1 will come here, and this will be zeros. That is left shift A. That's the step 1. Step 2, subtract A from M. A is equal to A minus M. Okay, see A, this is A, right? And write M here, minus M actually, because you are doing A minus M. So write minus M here and A here. This is M. M is 3. Find the binary equivalent of minus M and write here and add both. A plus minus M, that will be equal to A minus M, right? So add these both and you will get an answer here. Now what you need to do in the step 3, if this sign is 1, see the last sign here, AN. This is known as AN. Write the sign, see here the sign, what is the sign here? If it is 1, what you need to do, you need to make this 0 here. First you have left shifted, one empty space was there here, right? That you need to make as 0. If it is 1, it will be 0. If it is 0 here, it will be 1. Okay, understood? Now if AN is 1, means if this is 1 here, what you need to do, A is equal to A plus M. A plus M, this is A. You need to add M. Write M here, which is 3. Binary equivalent of 3 is 1 1. So add these both. After you add, you will get the answer here as 0 0 0 0 1. Alright, this is the first iteration of yours. Then in second iteration, again do the same, left shift A. Left shift A means 0 0 0 0 1 is there. This is A. If you left shift, one of the spaces will become empty and this whole will shift here. So 1 0 was here, it will come here. Okay, and this 1 will come here, this 0 will be coming here, like that. Okay, so again you need to subtract. A is equal to A minus M, and repeat the same things. After subtraction, you need to write A is equal to A minus M. So this one was A, which you got, and write minus M here and add both. you will get one thing. Then again, if sign is 1 here, what you need to do, you need to make the empty space as 0. So like that only same you need to do. But sometimes if sign is 0 here, like how you are getting 1 here, right? If it is 0 here, what you need to do, you need to make this as 1, and you need not restore that m. A is equal to a plus m, you need not do, you just have to copy this in the next step. Okay, after copying this in the next step, you have to left shift a. See, if sign is 0 here, you need not restore. Before you were restoring here, right? Because it was 1, you were restoring, adding minus m. Here you will use this same thing and again left shift a. Okay, then you do the same thing till the end until this all become boxes. Okay, that's when this step you reach, that will be the quotient, and the remainder will be this step what you will get here. Okay, this is non-restore division. So here we will not use a is equal to a plus m. Okay, instead what we will do, suppose consider an example 8/3, same things, register m, register q, write the value of m which is 3 and write the value of q which is 8. Okay, and after doing that, what you need to do, left shift a. Firstly a will be 0, when you left shift this 1 will come here. Okay, then an empty space will be there. Then you have to subtract here. If sign is 0, you will check this sign. If it is 0, you will add with minus m. Find the minus m, add it, and you will have an answer here. If sign is 1 here, what you need to do, you need to put empty space as 0. Then again in the step, again you will follow the same step. Left shift a means again one space will come here, and when you will left shift a, it will be 1 here. See here, if the sign is 1, you need to add a is equal to a plus m. If sign is 1 here, right? What you need to do, you need to add it. When you will add both, you will have here all 1 1 1 1. Okay, if you didn't understand this step, listen once again. First you left shift a here in the first step. After before a was 0 0 0 0. When you left shift a, this q, whatever will be the value of q, it will come here like this. So if it comes in a, it will be this 0 0 0 0 1. Then in the next step, what you need to do, after left shift, second step is you need to check this sign at last what digit is there. If it is 0, subtract. If it is 1, add. Subtract means a minus m. You can write a minus m as a plus minus m. Then add these both. A plus minus m is equal to a minus m only, no? So add these both and you will get an answer here. When you get an answer, the third step is to check this sign, and if it is 1, put the 0 in the empty space. Similarly, first step was what? Left shift a. This is a, right? Now when you left shift it, what will happen? Q is this one, 0 0 0. When you left shift it, another 0 will come here and this 1 will go off. So it will be, before 4 1s are there, now 3 1s will be there and 2 zeros will be there. Okay, the 0 came and sat here and the last one got off from here. So this is the left shift of a, and you need to check the sign. It is 1. So in case of 1, what you need to do, add means a plus m. You will write m here. This is 3, right? You will write m here and add these both. After adding, you will have 1 1 1 1. Again you need to check if the sign is 1 here. If it is 1, fill the empty space. Then again left shift a. After left shift, you will have 3 boxes here and 1 empty space, and this it was 1 1 1 1 1. So when 0 will come, 4 1 will be here. Then again do the same thing repeatedly until you get 4 boxes here. Okay, at last. That is the quotient. Okay, now after doing the last step, if you get all as 1 or any negative number, means at last here if the digit is 1, that means it's negative. What you need to do, add this with m. M is 3, right? So put the remainder here, whatever you get here, and plus m. M is 3. Write the binary equivalent, add it, and what answer you will get, that is the remainder. Okay, that's the remainder. If it is positive number, that's the remainder here, but if it is negative, you need to add m to get the remainder. Okay, that's non-restore division. Execution of a complete instruction, I'll tell you in a story. Okay, start from here. PC. What is PC? PC will have one address. Now suppose the instruction is to add 2 numbers. PC will have one address here. In that address, one number will be stored, like add R3. This is an instruction. So PC will have this number and it will send this address to MAR. MAR is memory address register. So in this address will be stored. This address will be fetched, and whatever will be the address will be there. That address, that instruction will be given to MDR. MDR is memory data register. So here the number will be stored which is to be added. So that will be sent to IR. IR is instruction register, and instruction register will send to decoder. decoder will decode the instruction. If you remember in this way, see 3 steps only. PC will have an address, address will have an instruction. First PC will send the address to this, it will fetch the instruction and send to MDR, MDR will send to instruction register, and that will send to decoder to decode what's the instruction. Now what does decoder do? This decoder will send this to bus, this is bus, okay. It will send the instruction and the number what to do, and when it will come here, it will come inside B, okay. Y will already have another number which is to be added. Suppose it is 4, so this 4 will be here and it will come to A. So A and this new digit which came, A and B will be added by arithmetic logic unit and it will be sent to Z, and that's the way you add the two numbers. This is an execution of a complete instruction, and this is a structure of a bus, okay, single bus. See, it's very easy. This is instruction register, start from here. These are registers to store some numbers, okay, and this is decoder which will decode what the instruction is, MAR and MDR, okay. In this what you will have, in that you had only one, in single bus structure you will have 3 buses here. It's very simple. Start from here. PC you had, PC is counter, this is register for storing the final answer, this is arithmetic logic unit, okay. This is the most simplified version of the multi bus structure. This is instruction register, it will fetch instructions, MDR, MAR, this both will be having, and this has all the connections with C. Now let's see an example of this and it's working, okay. Suppose you need to add 2 numbers. In this case what you will do first PC will have add 4 and add 5, these 2 instructions PC will have. These 2 instructions will be sent to MAR. First suppose there is a memory location here, okay, this is the memory. In that memory, this is the number stored as 5, this is the number stored as 6. That addresses will be sent to MAR. PC will send 4th and 5th address to this one. 4 is stored at location 12 and 5th is stored at location 123. So MAR will have register the addresses of these numbers, a memory address register, and this address will have what value, that will be sent to MDR, data, memory data register. It will have the data. When it gets the data, what it will do, it will send to respective buses simultaneously. Before one after the another it was happening, this will happen simultaneously. 4 will be sent to bus A, 5 will be sent to bus B, like this. This is bus A and bus B, okay. Now what will happen, bus A will send to ALU in A input, B will send to B input, 4 will come from here, 5 will come from here at the same time. It will get added and it will get sent to bus C, okay. That's what happening here. ALU will add both numbers and send to bus C, and C will send to register in the final answer. This C will send to register. That's the working of multi-bus structure and adding 2 numbers. You have 2 types of control, hardwired and microprogrammed. In hardwired, IR is there. This is the instruction register. Whatever the instruction will be there in the computer, that will be stored in the form of 8 bits. Suppose this is an instruction like add or subtract something, okay. So that instruction will be sent to instruction decoder. What is this 11001 mean? That in instruction decoder there will be many combinations, okay. So what combination will be there? This, if it matches, that will be activated. So that instruction will know what to do with that instruction. That will be sent to encoder. What encoder will do? It will get some external inputs and the conditions and step decoder. These 3 things it will get, and it will generate control signals. Means if it is add, it will generate the signals to add. If it is to continue with the process, it will continue, or if it is to end, it will reset the instruction register here, okay. So if it resets, this process will get over here. That's the working of hardwired control. Microprogrammed control is very interesting. See here, you will have some sequence of bits 1 0 1 1 0 1. This is called a micro information, okay. That means like input A B, okay, takes input of A, input of B. Now if you join many of these instructions like this, take input of A, add these both and store the result, that all is known as a micro routine, okay. Micro routine means add 2 numbers. For subtraction, one micro routine is there, like all that. Multiply, one micro routine is there, which has the following sequences of instructions. That all instructions will be stored here like this in the form of small files, which is known as control store. It will be like micro routine for add numbers, micro routine for subtract numbers, like that and so on. That whole data storage is known as control store, okay. Now suppose I need to add 2 numbers. What I need to do? I need to go to micro routine of adding 2 numbers. Then the instructions will be executed in this fashion. Now see, it will be starting from here, and all the instructions will be executed, and counter will count the digits from how many instructions have been executed, and the number of executions, if it reaches the end, this counter will stop, all right. That is known as micro counter. Now there is one more topic here, which is next address micro instruction. See, for instruction to happen here, instruction will happen here, it will go to other place to get the address of next location. So it is time consuming. So what they can do, they can have the next address within the micro instruction here as well, okay. So the process will be faster, but this has one disadvantage, that you should have another extra bit which will cost more money, okay. That's next address micro instruction, next address micro instruction, all right. Pipelining is the last topic. Suppose there was a news, okay. For that news you need to publish it. So we'll contact the paper factory. They will produce a lots of paper, and the person will write in each paper, okay. He will write what is the news, and the errors will be detected after writing the news, then it will get printed, okay. That's very time consuming, because after this gets over, all the papers come, they will start writing, and after this writing gets over, this will happen and this will happen. So it will take approximately 5 hours for each task. 1 2 3 4 tasks will take 5 hours. But suppose they will what they can do, within when a few papers arrive, they can start writing, and at the same time send for verification and take new papers and write at the same time. In that way they can reduce the time, right. So that is known as pipelining, doing the task simultaneously. In computer also there will be many things in that. If they can see which task can be done simultaneously, if they do, they can complete the task within the time, I mean lesser time. See, 5 hours are there here, it's 4 hours here, some tasks are being overlapped, okay. So they can do it more effectively. That's known as pipelining.